In this video, we're going to talk about the Fibonacci sequence. Hello everyone, my name is Kathleen Dentejones and I am your instructor for this subject, Mathematics in the Modern World. So now, let us go to our topic. But before that, let us define what is a sequence. So sequence is an ordered list of numbers called terms that may have repeated values, and the arrangement of these terms is set by a definite rule. So, may have repeated values but pwede ring wala. So, these are some arrangement of numbers. So, now let us go to Fibonacci sequence for us to be able to differentiate or define more this sequence. But before that, let us have a short history about our Fibonacci sequence, of course. So, Fibonacci sequence is named after the Italian named Leonardo Pisano Bugoglio. Sorry, it is Leonardo Pisano Bugoglio from 1180 to 1250. So, who is known as who is known in mathematical history by several names. So, you might be thinking, ang layo naman ng Fibonacci dun sa pangalan niyang Leonardo Pisano Bugoglio. So, he has different nicknames. So, the first one is Leonardo Pisa. Pisano means from Pisa. So, and we have another nickname for him, which is Fibonacci. So, dun nakuha yung name na Fibonacci sequence, which means son of Bonacci. So, Fibonacci Day is in November 23rd, as it has the digits 1, 1, 2, 3, which is the first part of the sequence. So, if you have a background idea about Fibonacci sequence, the first terms are 1, 1, 2, 3. So, yun na. That is the Fibonacci Day. So, here's the list of some terms of the Fibonacci sequence. We have 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, 144, and so on. So, if you're going to observe, the 2 is found, or let us go to 1 first. 1 is found by adding 2 numbers before it. 1 plus 0 is equal to 1. Let us go to 2. 2 is found by adding the 2 numbers before it also. We have 1 plus 1 is equal to 2. And also we have 3. 3 is found by adding 2 numbers before it. 2 plus 1. So that is the Fibonacci sequence, and so on. We also have 5. 5. We added 2 numbers before it. 2 plus 3, 5. 3 plus 5, 8. 5 plus 8, 13. Ganun yun. So, the Fibonacci sequence can be written as a rule. First, the terms are numbered from 0 onwards like this. So, we have here the table. So, the term 6, or the sixth term, which is 8, is called f of 6. Therefore, if we're going to have our formula, we can have it as f sub n is equal to f sub n minus 1 plus f sub n minus 2. Wherein f sub n is the term number or the nth term, f sub n minus 1 is the previous term, and f sub n minus 2 is the term before that. So, if we're going to check it, o kung tama ba yung formula na gagamitin natin, we can have this part as our example. What if we're looking for the f sub 6 or the sixth term for the value? Of course, walang table-table. What if iba yung given or up to 5 lang yung given? What are you going to do? So, let us substitute. If we're going to find f sub 6, f of n minus 1. It means 6 minus 1, it will be 5. F of n minus 2, it will be 6 minus 2, it will be 4. It says that we're going to add f of f sub 5 plus f sub 4. So 3 plus 5, it will be 8. And this is the value of our f sub 6. Ganun yun. So we have here our example. Another example. Find the 13th term in the Fibonacci sequence. So we have f sub 13 is equal to f sub 13 minus 1 plus f sub 13 minus 2. So f sub 13 is equal to f sub 12 plus f sub 11. If we're going to take a look at the chart, what are the values of our f sub 11 and f sub 12? It is 89 plus 144. And if we're going to add 144 and 89, we will have 233. And if we're going to take a look at the chart, it will be equal. 233 is equal to 233. Therefore, the 13th term in the sequence is 233, or f sub 13 is equal to 233, or in other symbols, ganito ang gamit nila, yung may parenthesis, Fibonacci of 13 is equal to 233. How about we have here as an example? Paano kapag ganito ang given? Determine whether the statement 3 times f sub n minus f sub n minus 2 is equal to f sub n minus 2 for n is greater than 3. So first, let us set the value of our n. Since we have here greater than or equal to 3, of course, we're going to have the values from 3 pataas. So since 3 is the smallest, since mas malaki or mas madaling i-compute yung mga smaller numbers, of course we're going to choose smaller values, so which is 3. So we'll substitute this to the formula. Then we can have this. 3 times f sub 3 minus f sub 3 minus 1 is equal to f sub 3 plus 2. 3 times f sub 3 minus f sub 1, 3 times 2 is equal to 1. And 3 plus 2 is equal to 5 is equal to f sub 5. So if we're going to take a look at our chart, f sub 3 is equal to 2, f sub 1 is equal to 1, and f sub 5 is equal to 5. So ang gagawin lang natin is to substitute. So 3 times 2 minus 1 is equal to 5. So 6 minus 1 is equal to 5, and 5 is equal to 5. Therefore, the statement 3 times f sub n minus f sub n minus 2 is equal to f sub n plus 2 for n is equal to greater than 3 is true. So, that is true. So now let us go to the golden ratio or golden mean. So the Fibonacci sequence has many interesting properties, and among this is that the pattern is very visible in nature. Some of nature's most beautiful patterns, like the spiral arrangement of the sunflower seeds, the number of petals in a flower, and the shape of a snail's shell. So things we looked at earlier at the earlier chapter or the earlier lesson. So all contains Fibonacci numbers. So it is also interesting to note that the ratio of successive Fibonacci numbers approach the number phi, also known as the golden ratio. So this is approximately equal to 1.618. So if we're going to divide it, yun, approximately 1.618, especially if these are greater numbers on this part. If you're going to take a look at the chart, almost 1.618. Habang lumalaki, mas nagiging, yung ratio is nagiging 1.618. So the golden ratio can also be expressed as the ratio between two numbers, which is A over B is equal to A plus B over A. So if the latter is also the ratio between the sum and the larger of two numbers, so geometrically, it can also be visualized as rectangle, rectangle, so which can be repeated infinitely inside each section. If we're going to take a look at the drawing naman or the diagram, you can see that papalaki ng papalaki yung mga rectangle. So this golden ratio can be used in solving Fibonacci numbers, but I'm not going to teach you how to solve for those because those are higher order math wherein hindi nyo naman kailangan. As long as you know the basics in Fibonacci sequence, of course, yun na lang ang gagamitin nyo since you are not all majors in math. So, that's all for this lesson. Thank you for listening. Always remember, prevention is better than cure. See you again on my next video.